In this video, we will learn about a new package called Pandas in Python. Pandas is like a high-level data manipulation tool, which becomes a very popular, and especially when we are doing data analytics and the machine learning and some of the other applications of data science. It is basically built on top of NumPy package, and the key data structures in the Pandas is called a DataFrame. DataFrame basically allows us to store and manipulate the data. It's kind of similar to like a spreadsheet where we have rows and the columns, and then it provides a bunch of different functionalities, like you can do filter out the values, you can create a new columns out of the existing ones, you can do descriptive statistics like min, max, standard deviations, you can do a lot of different SQL stuff like aggregation values through group by and some other functionality as well. At the same time, it also provides a functionality to create some of the visualization charts as well. So there are plenty of things which we can do through the Pandas library. So that's what we are going to learn in today's video. So let's jump into the Pandas notebook and let's do some kind of a hands-on exercise and learn more about the power of Pandas packages. Now the first thing in the Pandas package is called the Pandas series. So Pandas series is similar to like a one-dimensional array or a list, or you can think that in the spreadsheet where you have only one column but you have a multiple rows in it. And at the same time, Pandas series can hold elements of a mixed data types. It doesn't have to be a similar data type like in the case of NumPy, but in the Pandas series data structure you can have elements from a different variety as well. So let's see one example and see how it looks. So I have created a salary list, It has 5 elements, basically storing the salaries of 5 employees, which is 10,000, 20,000, 30,000, 40,000, 50,000. So in the next, I'm printing this salary list, and secondly, I'm also want to know or to print the data type of this list. So as we know that the function type can be used to know the data type of any variable. So let me run this cell, and after running this cell we can see that the salary list is showing the 5 elements what we have stored, and the data type is class list. So basically it belongs to the list variable. Now this is how we typically create a list, but we can create a Pandas series out of a list. So the function is very simple. Before we start using any functionality of the Pandas, it's important to import the Pandas packages. So the way we import or install any Pandas package is through this command import, then the name of the package, which is Pandas, and as PD. So as we know that I'm giving as alias as PD because whenever I will going to use Pandas functions, I will refer this package as PD. I mean, you can also refer to as Pandas, but again, if you're using multiple times, then it's like typically you're typing 5 characters or 6 characters, which is Pandas. But when you give an alias name, now you just have to type 2 characters. So it's just a convenience way. But again, if you don't want this PD as alias, then you have to write down Pandas complete word whenever you want to use any packages of the Pandas. So now in the next cell, what I'm doing is to convert the list into a Pandas series. So the function is simple PD, which we have given already the alias of the Pandas PD dot, and then I'm using one of the functions which is available in the Pandas package, which is called series. So this would be the word series for the function, and then inside the round brackets you will provide the name of that list, which is in our case is salary underscore list. And then I'm storing this series into the variable called salaries underscore list underscore series. So next what I'm doing is to print the salary list series as well as printing the data type of it. So let me run this command first. So as you know that in order to use any kind of a functions in the Pandas, it's important you should include this particular command, import Pandas as PD. So now I'm running this cell. So we can see that it's giving me a salary list and the list of all those values, which is 10,000, 20,000, 30,000, 40,000, 50,000. Now we can see if we compare the list and the salary list, if you compare the list and the Pandas series, output is same, but if you see the the way it's printing the values is looking more like an Excel spreadsheet, like a one column with multiple values in the case of series. So then in the Pandas series, we can see the output in more like a spreadsheet kind of a format. So in this, we have one column with multiple 5 values. Now another thing what in the series, what we can do in the Pandas series or even in the other data structures of Pandas, we can also give the names of rows as well. So the rows by default, it's giving the name as 0, 1, 2, 3, 4, and then we can refer to any row through their names. So that's a part is not available in the list, but in the Pandas series or maybe in the Pandas data frame, we can also give the names or the labels to the rows as well. So when we run here, it's showing the data type is pandas.core series. So it's basically means the salary underscore list underscore series is a Pandas series. Now, as I mentioned that, in the Pandas series, we can also give the names to the rows or the observations. This is how by default it gives you 0, 1, 2, 3, 4. So for example, in this case, we didn't mention anything about the index. So by default, the names of the rows would be given as 0, 1, 2, 3, 4. Now, if you want to give more meaningful names to each observations, then the way it can be done is to first put the name of the data, which is salary underscore list in our example, and then you have to put comma and then index equal to name of all the observations. So since we have 5 observations in our example, so the first observation name I'm giving the John, second as Mark, third as Nancy, fourth as Chris, and fifth as Jeremy. And now what I'm doing is printing those values and their data type. So now we can see that I'm storing in the salary underscore list underscore series. It's showing employee ID because maybe in the print I have given the employee ID. So don't get confused here. It's just a printing thing. But the important is the values inside it. We can see now we are also getting the meaningful names of each observations, which is John, Mark, Nancy, Chris, Jeremy, and along with their salary. So we can see that the format looks very meaningful, like an Excel spreadsheet. It's easy to understand, it's easy to view as compared to some of the way we see the output in the list. So the next part what we will going to learn is to how to access the elements of a Pandas series. Because that is very important. Now we have created a Pandas series, but it's important that how can we access the elements of Pandas series. It's very simple, the way we have done in the previously in some other examples in the list or tuples or dictionary or some other data structures. Similarly, we can do here. So for example, we have salary underscore list underscore series, which has like 5 observations. So let's assume I want to access the elements from 1 to 3. 1, 2, 3. So as you know that in the Python, the indices or the index or the location number start from 0. So 1 here means is 2000. And as you know, when we provide the destination number, which is 3, so basically it will go till 2. So 2000 and 3000. So I am expecting the output to be 20,000 and 30,000. And that's what we have got. So we have got the output as Mark 20,000, Nancy 30,000. So 20,000 and 30,000 are the values, and the Mark and the Nancy are the labels or the names of each observations. Similarly, I can access, if you want the elements to be print from 20,000 and 30,000, then you can go 1:2. So it will give you Mark 20,000. And if you want to access only one particular element, you can go with like 1. So 1 basically stored 20,000 here. So it basically will store 20,000. And in this example, we are storing 1:2. So basically 1 and 2. As you know that when we provide the destination number 2, so it will go only 1. So basically it will going to output only the one element, which is 20,000. And that's what it's printing, Mark 20,000. So now let's talk about the next topic, which is how to add or subtract in the Pandas series. Now, before I showcase you how to add or subtract to Pandas series, let me go back to the list one, the list example. So here I have created two lists, salary underscore list and salary underscore list 2. So as you know, when we try to the add to list, we get some very unexpected output, and we can see from that output itself, it's look like that it has got concatenated. Instead of adding the two numbers, it has just appended the to list or concatenate the to list. Now that's a limitation in the case of a list. That's why we typically use NumPy array or maybe now the pandas. So in the next step, what I'm doing is to convert this list into Pandas series. So as we learned that, to convert the list into Pandas series, it will be done through pt.series, and then you will enter the list values. And similarly, I'm doing for the second one. So I have created two series now, which is salary underscore list and salary underscore list 2 underscore series. Now when I try to add these two series, I'm getting this output, which is look like the way we were expecting. When you add two numbers, this is the output I'm expecting, like 10,000 plus 20,000, which gives me 30,000. Then it will add 20,000 plus 50,000 gives 70,000, and then 30,000 plus 90,000, it will give me 120,000, and so on. So that's how the output we were expecting, and that's what we have got through Pandas series. So Pandas series, again, it's a very useful and very important when it comes to doing mathematical operations. And then same thing we can do, we can subtract the same way. So we will get the subtraction of two series, which is minus 10,000, minus 30,000, and so on. So this is how we can do in the Pandas series. Now the next question comes up. See, in the Pandas series, it's good, it's doing a lot of good stuff, but the problem here is that it only have like one column and multiple rows. But in day-to-day analytical world, this is not the scenario. In the real world scenario, we will going to have multiple columns and multiple rows. Now in this case, data series will not be very helpful. Again, Pandas data series would have a very useful application or very useful functionality in different use cases, but when it comes to have multiple columns and the multiple rows, that's where the power comes in the Pandas data frame. So the Pandas data frame is another data structure in the Pandas package, which is basically have like a two-dimensional data structure with columns and the rows. The way in the Excel spreadsheet you have multiple columns and the multiple rows, similarly the Pandas data structure would have the similar kind of a format. And along with it, it will bring a lot of different functionality, lot of statistical functionality, data analytics, machine learning, visualization. So it's very, very powerful and very popular among the analytical world. Now the next question comes up. Okay, I think it's very useful, but the next question comes up: how to create data frames from list or tuples or dictionary or some relational databases or the spreadsheet or the random values. Now for the sake of this video, I have picked some few data sources, which is creating Pandas data frame from list, tuples, dictionary, random values in the CSV spreadsheet. But again, it's a very limited list, but you can connect the Pandas data frames or Pandas packages with any number of databases, whether it's any kind of a relational database like any kind of MySQL or maybe S3 bucket or Athena or any other data which is providing. It has given all the connectivity to connect your data sources with your Pandas notebook. But for this video, for the explanation of a Pandas package, we will be only restricting to CSV spreadsheet. Now the first way to create Pandas data frame from list is in this way. So it's simple. In the first salary underscore list, I'm creating a list which has 5 elements. Now I'm creating a data frame or a data frame data structure. So the way we create this one is pd dot, then this is the keyword data frame. So this is how Python will understand or recognize that we are about to create a Pandas data frame or a Pandas data frame data structure. So important, D would be in caps and same F would be in the caps. Then inside the brackets, you will pass the name of that list, which is salaries underscore list, comma. Then the good part is that you can provide the column name as well. What is the column name you want. So here I'm giving column, that is again the keyword, equal to salary. So here I'm creating a data frame which has 5 values and the name of the column would be salary. So we see that in the list or the tuples you are not able to create those columns or the column headers, but this was overcome by the dictionary. In the dictionary we can create the column headers, but that's the same thing we can do in the pandas data structure. We can create this kind of a format, and when we run it, we can see that it's showing the column name as salary along with its 5 values, and these are called index. 0, 1, 2, 3, 4 are index, or the name of the rows, or the label of the rows, or the label of the observations, or the names. So in the pandas packages we can give the names for each individual observation as well. That's what pandas series also do the same thing. So we can see that, and the good thing about the pandas output is that when you see the output, it looks like exactly like an Excel spreadsheet. It's so easy to understand, so easy to view when you compare with a list or a tuple or a dictionary or any other data format or a data structure. Now in this example, what I'm doing is that, as I said, that index, if you don't provide the name of any index or the row names, then by default it will come as 0, 1, 2, 3, 4. So in this example, I'm adding one more thing. So I'm adding the salary underscore list, which has 5 observation. Then the column would be same, that salary. But here I'm adding index equal to the name of each observation or the name of each row. So when I run it, it will show me the output as the column salary with their values, and then this is the index or the location number or the row name or the row number. Now in the next example, I want to do a more like a 2D kind of array or 2D kind of a format where we have multiple rows and the multiple columns. So the way what I'm doing is creating 2 lists, salary list and the salary list 2, each have 5 observations, and then I am combining or joining this salary, both the list into one through this functionality, zip. So zip is the function will combine multiple lists into one, and the output of this zip function I'm converting into the list. So first zip will combine these 2 lists into one, and then convert it into a list data type. And then since there would be 2 lists or 2 columns, so the name of the 2 columns I'm giving salary and salary underscore 2, and the index would be the same, John, Mark, Nancy, Chris and Jeremy. So when I run this cell, I will get this kind of output, salary and salary underscore 2. So we can see that there are 2 columns with 5 observations, and again it looks so beautiful. Like the format is very easy to understand, very easy to visualize. So this is how we can create pandas from a list. Now let's move on. How can we create the pandas data frame from a tuple? Again, exactly same. I'm creating a salary tuple in this way and passing the values exactly same, salary underscore list, and then columns is equal to salary. When I run it, it will give me that salary tuple data type is tuple, and these are the name of the column is salary, because here we are passing the column name as salary. These are the values and the by default. And similarly we can similarly we can add the multiple tuples into data frame, and this is the way the output will look. Exactly same like list, so I'm not spending too much time on explaining this part of the cell. And the next part is how to create pandas data frame from a dictionary. So again I'm creating the same tool list, then I'm creating a dictionary. So as you know, the dictionary will be done through those curly brackets, so this is how Python will recognize. Then this salary 1. So as we know that in the dictionary we can provide key, or in the simple way I can say it's a column name or a column header, and then colon, and I'm passing the values, salary underscore list. These are the values, and then I'm creating another column where I'm giving the column name as salary 2 or a key salary 2, and I'm passing this value, salary underscore list 2. So this is how I'm defining this salary underscore dictionary variable, and then simply what I'm doing is pd dot data frame, and then passing this variable salary underscore dictionary, and done. And you will see the output, salary 1 and salary 2. So the advantage of dictionary is that you don't have to explicitly provide the columns here the way we were providing the previous examples, because in the dictionary we have already provided the column names here itself. column names, or in the case of dictionary we call it as key. So we have already provided the column name, so we don't need to provide explicitly the column names again during the Pandas data frame. And since we have not provided the index names or the row names, so by default it's taking 0, 1, 2, 3, 4. In the next example, in this example, I am passing the row name as well, which is John and so on. And we can see in the output there are 2 columns are there along with their row names as well. The next part, what we are doing is how to create data frame from random values. So this is very simple. In order to provide the data, I am passing this random function randint np, which is coming from the numpy.random.randint, and passing this value. So what does it mean is that first understand this 5,2, which means we need 5 rows and 2 columns. 5 rows and 2 columns. Since this is a random value, so I want the random values to become from between 10,000 to 50,000. 10,000 to 50,000, where 10,000, this is inclusive, but 50,000 is not inclusive, it's exclusive. So it means that basically the random values will be picked between 10,000 and 49,999. Since we are creating 5 observations and 2 columns, I want to give the name of those 2 columns as salary 1 and salary 2. So when we run it, we get this output, salary 1, and these are all the 5 random values. So this is how you can create the random value. So if somebody asks you, hey, can you create a data frame using some random values, this is how you can use it. By using the numpy package will give you these 2 functions, randint, and then you will pass on whether you want how many columns and the rows. So in our example, we want 5 rows and 2 columns, and their random values should generate between 10,000 to 50,000, and the name of those 2 columns would be salary 1 and salary 2, and this is what the output we are getting. And the next way we can create a Pandas data frame is through spreadsheet or the CSV file or the Excel file. So let's say we have already created a CSV file. It is stored in our local machine or a local desktop or in our local laptop. So the way we can access any spreadsheet is through Pandas package, and the name of that function is called read_CSV. So basically it will read your CSV file, read_CSV, and then inside the circular brackets you will provide the location of your file and the name of the CSV file. So this is the CSV file I am planning to read, and done. And we can see that DF has stored, it has read that train.csv file, which has these many columns, and these are the rows and their values. So now we have learned how to create the data frames. So the next step is how to access the elements or how to access the values of data frame. Or in another way we can say, how can we do the slice and dice of a data frame. So instead of reading the whole data frame, how about picking the subset of a data frame. So there are many ways we can access the elements or slice or dice data frame. So let's say this is the data frame what we have loaded in our CSV file or from our CSV file. These are the list of the columns and their values. And let's say I want to know the values of these columns, the count column. So count is one of the column, and I want to know what are the values present in that column. So the way we can do is because the CSV file what we read, we have stored that file in the variable called df. So now we will put df, and inside the square brackets we will name the column which we want to see. So here in our example we want to see the values of count. So df square brackets count, and when I run it, I will get their values. Now the next thing is that, hey, I don't want to see all the values of a column count. I just want to see the first 5 values of the column count. So the way we can do is df, the name of the column which is count, and 0:5. Basically it will pick the first 5 observations of that column. So now when I run it, I will get the 5 values. So 16, 40, 30, 32, 13 and 9, which is not a number, and this is the same values it presents, 60, 40, 32 and so on. And same way we can see that, hey, I want to see all the columns of the data frame, but just the 5 observation, the first 5 observation of all the columns. So the way we can do is to df. So df is the variable where we have stored our CSV data, and then inside the square brackets the starting number and the end number. So now we can see that we are getting the 5 observations of all the columns. So in this way you can do a quick peek of your data frame, you can access the values, you can store this 5 observation in a new data frame as well, or in a new variable as well. So this can be very handy. Now the another thing what we can do here, we can see that, hey, I don't want to see the values of all the columns, I just want to see the values of some selected columns. So let's say I want to see the values of date, time, season and then count. So the way we can see in this way is to name those 3 columns separated by comma, and then you have to pass 2 square brackets in the beginning and then the 2 square brackets at the end. In this way it will tell you the date, time, season and the count and their values linked to it. Now there are other ways also we can do the slice and dice or access the element is through 2 functions. What Pandas provide is LOC and the second is ILOC. So location based. So LOC stands for location based, where whenever you need to access the values, it's important you also provide the name of that column. So only the location number or the index number will not work, so you have to pass the column name as well. So for example, in this location, in this example, I'm passing df, which is the variable where we have stored the CSV data. .loc is the name of the function, location based. Now I have put inside the square bracket first the row numbers. So 0, 10, 20. So it will pull the 0th number, 10th row number and the 20th row number, comma, then another square brackets, and inside the square brackets I'm passing the name of those columns. So date, time, season and the count. Now it's showing me the 3 columns, which is date, time, season and count, and 0, 10, 20 are the row numbers or the index number. So 0, 10, 20. So these are the 3 values present. So the next what we are doing is to access the elements of data frame using the index number. So now instead of passing the column number or column name or something, we are passing the index number. So in this example, df.loc, I'm passing the index number, which is 1, 10. So it's basically it will pick all the columns because we have not given any column name. So it will by default pick all the columns, and since we have passed the row number from 1 to 10, it will pull the first 10 observations for each of the columns. So in our data frame we have this many columns and it will pull all the 10 observations. But as I said that when you use the LOC, it's important if you want instead of seeing the output for all the columns, if you want to see the output only for the selected columns, then in the LOC it's important to name the column name or to pass the column name. If you don't pass the column name, then it will throw an error. So let's see an example. So what I'm doing is 1, 10, comma. So before the comma, I'm telling what are the rows it needs to pick. So I'm telling that, hey, before the comma 1, 10. So from 1 till 10 pick all the observations, and after the comma, instead of passing the column name, I am passing the column number. So let's say the column number would be date time would be column number 0, season would be column number 1. So I am passing the 1. So as I said, that the problem with the LOC function is that the column name has to be column name. It can't be column number. So when I run it, it will throw an error because LOC is expecting a column name, not a column number. So now we can rectify this kind of a problem through a different function it provides, which is ILOC. So ILOC is the function where you can pass the row numbers and the column numbers. So for example, df.iloc. So before the comma, I'm telling the Python is that pick the observations from row number 0 till row number 10, and after the comma, I'm telling pick the column number from 0 to column number 3. Now it will give you. So iloc, that's a good thing about the iloc, is an integer based location or the index based location. So index based location, remember, integer or index based location. So here if you try to pass the column name, then it will fail. So iloc expect that your both row number and the column should be some kind of an integer number. Now in this example iloc, what I'm saying that in the square bracket 1 comma 4 means only pick row number 1 and row number 4, and then after the comma in the square brackets I'm telling 0 comma 2 means pick only the column number 0 and column number 2. And that's what the result we have got, daytime and the holiday, observation number 1 and 4. Now as I said that there is a limitation with iloc is that if you try to pass the column name in the iloc, column name, not the column number, column name, then it will throw an error. Because iloc is an index based location or integer based location, so both row number and the column should be an integer value. Whereas with loc, it expects that your row number can be integer or can be numerical, but your column should be a column name. It will not accept a column number. So for example, df.loc, what it's doing inside this square bracket, 1 comma 4 means pick observation 1 and 4, and then after the comma I'm telling them which are the column it has to pick. So I'm telling date, time, season and the count, and it's on. So in this way we can do a slice and dice. In this way we can do we can access the elements of a data frame through different ways, what we have learned in this video. Hello everyone. So in this video we will learn about the Pandas functions. So these are the certain functions which are quite popular among data analysts or the data scientists or a data science community or business analyst community, because these are the functions which give you the way where we can do all kind of analysis, whether we want to find out the descriptive statistics or we want to do some kind of aggregation based on some group by, or if we need to do some kind of filter values, we need to do some kind of a crosstab, mean, median and bunch of different stuff. So Pandas have been very powerful. So let's get started on the Pandas functions. So the first one is head. So as you see that there are many times in the previous example I was using this head function. So what head function will do is to showcase the first 5 records or the first 5 rows or the first 5 observation by default. Now df is the one where I upload the CSV file and store their output in the df variable. So I can show it again. So this is the command what we used to load the CSV file. This CSV file will get stored in this variable df. So now whenever we want to use any kind of a Pandas function, we will use on df, because this is a df variable where we have stored this CSV output or CSV file data. So the first function is head. Head basically will give you the preview or the snapshot of your data frame or the data. So by default, it will show you the 5 rows. So you can do a quick preview of your data, and let's say instead of 5 rows, you want to see more than 5 rows. So the way we can do is to pass the parameter, and let's say here I'm passing 10. So here I want to see or display the 10 observations. So these are the 10 observations we can see as a preview. It will show you the list of all the columns and the 10 observations. And df.tail will give you the preview of the last 5 observations or the last 5 rows. So the tail basically it gives you the last 5 rows in your data set. So these are the 5 observations are there in this particular file or in this data set. And head, as I said, it will give you the first 10 observation of your data set. It's not a random, but the first 10 observations of your data set. The next function is a shape. So, I want to know how many observations or how many rows and columns are there. Now we can do through shape function. So df.shape. So df.shape will give you the rows and the observations, or the rows and the columns. Now when I pass df.shape and then and the square bracket as 0, it will first give me the row, how many rows are there, and when I give 1 inside the square brackets, it will tell me how many columns are there. So let me print it out. So df shape, it giving me 10886 as rows and 12 as columns, but you can individually find as well by using this index number, which is 0. So it will give you the number of rows, and 1 will give you the total number of columns. Then next we can also see what is the size of my data set. So df.size will give you the size of my data set. So the way it's computing the size is rows into columns. So number of rows into columns. So in our data set, we can see that it's 130632. So it's basically multiplying this number into 12. So now you can see that, hey, size of my file has like 130632. That is a size. And we can also see what is the length of my data set. So length of my data set basically will tell me how many observations are there, how many rows are there. So you can access the number of rows in that way also. len, which is one of the function, df. The next very important function is df.dtypes. .dtypes. So basically it will tell you what are the data types of each columns. So we can see that datetime has an object. So right now it reading datetime column as a string column. So in Pandas language, it's called object. So season as integer, holiday as float, and so on. Now df.info will tell you how many, what is the data type. Secondly, it will also tell me that in each of the column, how many null values are there. So for example, we know that the total number of observations or total number of rows are 10,886. So we can see that in datetime, the same number has non-null, means there are no null values because it equal to the total number of observations or total number of rows. But if you see in this case, it's showing 884. It means there are 2 observations in the holiday column which are null values. And similarly in the count, it's showing 883. So we can see that if we compare with total number of observations, there are 3 observations or 3 rows in count column which has some null values in it. Now describe function. So df.describe will give me some kind of a statistical analysis. So now it will tell me that for each of the column, how many number of observations are there, what is their mean value, what is their standard deviation, minimum value, what is their 25% percentile, 50 percentile, 75, and what is the max value in it. So in this way, it will give you a quick statistical analysis about your data set. And by default, if you don't pass any parameter, it will only tell you the statistical analysis of your numerical columns. But if you in your data set, if you have some kind of a categorical values as well, in order to see their statistical analysis, you need to include a parameter called include is equal to all. So all means include all the columns in it. Now it will tell you the date, time, season, because date, time, season are defined probably as object or maybe some categorical value. So that's why now it's coming here, and you can see that for that there is it will tell you the frequency and the top and some other bunch of different unique. So it will add some other which is more relevant for the categorical columns. The next thing what we can do is using this function called df.columns. So df.columns will basically tell you the name of your columns. So in your data set, let's say if you have 13 columns, it will provide the name of those 13 columns. So in our data set, these are the name of the columns what we have. So df.columns will give you the name of all the columns. So the next topic we will understand is how to rename any column. So there would be scenarios when you want to rename the columns to look more logical and more easy to understand. What would be the nature of the data inside that column. So the way we can rename the column in the Pandas data frame. Before we rename the column, let's do a quick snapshot of our data just to make sure what we are expecting. So when we run it, we can see these are the set of columns, and let's say we want to rename 3 columns. Let's say date time. Instead of date time, let's rename to date. Instead of temp, let's say rename to upper temperature, and instead of a temp, let's rename to low temp. So the way we can rename in Pandas, we will use a function called dot rename. So df, which is the data frame where we have stored our data. So df dot rename, and then inside the circular brackets, we will mention our columns which we need to be renamed. So for example, in the curly brackets, so if you remember in the dictionary, we used to do alias of the column names. So that's what we are doing here. In the curly brackets, we will put first the original column name, then colon, and the new column name. So I'm renaming from date time to date, and then comma, the second one. So the temp, which is the original or the old column name, colon, and then the new column name, which is upper temp, and similarly a temp we are replacing to low temp, and then access equal to 1. So whenever we put access equal to 1, it means we are doing some operation on the columns, and whenever we put access equal to 2, it means we are doing some operations on observations or the rows. So let's run this command and let's see what output we will get. And when we run this command, we can see that the snapshot of our output, we can see that date time has been replaced with date, temp with upper temp, and a temp replaced with a low temp. Now let's do a df.head and see if our changes have been reflected or not, because this is just it displays the output of this command what we have run. But let's check in df.head where the column names have been replaced or not. So when we run this df.head, we can see the column names have not been replaced. It's still showing the old column names, which are date time, temp, and a temp. So this looks quite weird because in this snapshot or in the output preview, it was showing the columns have been renamed, but when we did the df.head, it's still showing the same thing. So there are 2 ways to rectify this problem. The first one is this expression what we need to put it on the the output of this we need to assign back to df. So df equal to df.rename. If we go in this way, then we can see the actual changes of the column names, because in the previous expression we were just doing some expression, but we were not telling them to to update this new output in our older data frame. So here we are saying that, hey, whatever output you generate, just put that output back into df so that we can see the new reflected changes on the column names. Or the other way around, if you don't want to go df equal to this in this way, we can add this parameter called in place equal to true. In place equal to true. So what in place equal to true will do is that it automatically update the new changes into the old one. So whatever be the new output or the new changes it's doing, it will automatically override or update in your df. So in that way, you don't need to go in this way. So let's run this command and see if it works or not. So it's showing that it has done some operation. So let's validate through df.head. And we can see now in df.head that date time has been replaced with date, temp has been replaced with upper temp, and a temp have been replaced with a low temp. So this is how we can rename the columns to make sure that always check with this in place equal to true. So if you have not added in place equal to true, make sure that you assign back the output of this expression into your original data frame, which is df, so that the new changes get override or update in the older one. Let's learn how to drop the columns. So let's say I want to remove some of the the columns in the data set, which is irrelevant and it's not required for my analysis. So the way we can do in the Pandas data frame is using the function called drop, D-R-O-P, and then inside the circular brackets you will pass the name of the columns. So here I am dropping casual and registered users, so I have provided the name of those two columns. Then I told you x is equal to 1, I am telling them to do some operations on the column side, and in place equal to true, yes, do the changes, update the changes, whatever we have told inside this data frame, and done. And df.head, we can see that those two columns are no more available in this df variable. The next thing what we want to understand is how many null values are there in each of the columns. So the way we can do is df dot is null is the function which will find the null values in individual columns, and dot sum will basically aggregate and tell us how many total number of null values are present in each of the columns. So we can see that holiday has 2 null values, whereas count has 3 null values, and other column has no null values, 0. Then value underscore counts. So that is another good function which is provided by the Pandas package. Is let's say I want to know under season how many unique values are present, and let's say if there are 3 unique values, then what is the total observations in each unique value. So for example, in column season, I want to know how many unique values are there and how many total observations are there in each of the unique value. So the way we can do is df provide the name of that column, then dot value underscore counts. That's a function we can use, and it's telling me that hey, there are these are the unique values in this column, which is 1, 3, 2 and 4, and these are the total observations or total number of rows are present in each of the unique values. Similarly, I can do for working day as well. So I can see that working day has 2 unique values, which is 0 and 1. 1 has 7412 observations or rows, and 0 has 3474 total number of rows or observations. Then the next function what we can do is unique values. Now inside this column called holiday, I want to know what are those unique values. Just print me the unique value. You don't need to print out the total number of observations in each unique value. Just tell me how many unique values are present. So I can see that in the holiday there are 3 unique values, which is 0, nan, not a number, and 1. So and nan, I can say that it's a blank value or some kind of a missing values. So the next we will learn is how to drop null values from the Pandas data frame. That is very important because in real time scenario you will going to find the data sets which has some part of your data might have some null values. It can be due to some data entry thing, or maybe when you send the survey to a customer they didn't fill out all the information, so you will bound to see some kind of a null values. Now the question comes up, what to do with those null values. Either you can drop those null values, you can replace the null values with some legit values, but that's a topic for a different time. But here what we will learn is how to drop null values. Now, so the way we can drop this null values from our Pandas data frame, let's assume that you decided to drop those null values and we don't want to part of our data set. So the way we can drop the null values is, so we already know that our holiday column has, let me run it again. So we already know that our holiday column, has 2 null values. So let's see how can we remove those null values from our data set. So now you will be wondering like how this syntax has been written, because it's looking a little confusing, because df holiday dot is null and then I'm putting this expression inside the square brackets of df. So let's break down and let's see what the output we will get. So df holiday dot is null. Let's run it separately here. When we run it separately, as I said that df holiday dot is null will basically store the trues and false. Whenever it finds a null values, it will store true, and whenever it finds there is no null in that column, it will put it as false. So we can see that row number 0, 1, 2, 3, 4 doesn't have false. So there is some row where which is not showing here has some null values where it will be true. Next step is I want to see which are those two observation, or which are those observation where the df holiday is blank or a null. So the way in order to see those values is by using this expression. So we will put this whole expression inside the square brackets of df, and when I run it, it will show me that row number 11 and row number 12 has those null values in the holiday column. So we can see that holiday column has two null values, and these were those two observations. Now we know that there are two observations, and we can see those two observations. Now in order to remove those observations, we can use this particular concept. So we will use the drop na function, which is present in the pandas. Drop na, so means drop null values, then subset equal to the name of that column, holiday, and x is equal to 0. So I told you in the before as well. So when we put x is equal to 1, we are referring to column, and here since we are dropping the rows or the observation, we are referring here x is equal to 0 and in place equal to true, which we already learned now. So in place equal to true, basically all those new changes get automatically stored back into df. So when I run it, I think some operation has happened. Now let's verify whether the two null values have been dropped or not. So we can see that now the holiday has no null values, so it's 0. We can also validate by running this command. So we expect that this command should not display any kind of a null values, and it's not shown. So this is how we can drop the null values. Now the next thing is that, hey, I don't want to drop the null values. Instead, I want to replace the null values with some legit values. So the way we can do the same way. Let's identify which are those observations where count has some null values. So df count dot is null. We basically will tell me that these are the three observations are there where count has some null values. So as I said before as well, df count dot is null, basically it will identify which are those observations. Now in order to display it, we will say that, hey, filter those three observations from the bigger data frame. And now what we can do is use the replace function. So what I'm saying that df count dot replace, so in this column dot replace, first you will pass which value needs to be replaced. In our case, we want to replace the null values. So the way pandas will understand is through numpy package. So in the numpy package, there is a function called np.nan. So it will identify itself which are those null values, and then we are telling them replace this null values with count underscore mean. So count underscore mean is basically counting the mean of this column. So whatever be the mean of this column, the count column, it will replace the null with this value. And then in place equal to true, yes, update this replacement inside this column in place equal to true. And when I run df.isNull.sum, now I can see that all the null values either have been replaced in the case of count or deleted in the case of holiday. Now the next part is how can we add the column. So let's see the preview or the snapshot of our data frame, how it looks. This is how it will look. Now what we can do, we can add a new column as well. Based on the existing columns, we can add a new column as well. Let's say I want to calculate I want to find out the average of upper temperature and lower temperature and stored in a new column. So what I'm doing is that I'm doing df upper temp, which is this column, plus, because I'm adding up, plus df with the low temp, this column, and then the addition of those two I'm dividing by 2. So I am storing the output of this expression in a new column called mean weather. So in the df variable or data frame, we will see a new column called mean underscore weather, which is a combination of upper temperature plus lower temperature divided by 2. So now we can see that the new column has been added called mean underscore weather, and these are their values. 12.11, which is a upper temp plus lower temp divided by 2. Now let's say the next part comes up, how to update the values in the column. So let's say in the season I want to update some of the values. So let's say I want to update in the season column the first 5 values equal to 10. No matter what are the values of the season, just replace with 10 and it's done. So what it's showing that df season, that is the name of the column, and I'm passing 0:5, which means pick the first 5 observation and then replace their value with 10. That's it. And we can see that originally before this update command, the season first 5 values were all 1. Now it all has become 10 because we have updated to 10. And similarly we can do for working day. So for working day, what I'm saying is that just update the first value of working day column. So working day first value 0, replace it with 10. And we can see that working day first value has been replaced from, or update from 0 to 10. So this is how we can update the values of any of the columns. So the next part what we're going to learn is how to filter out the values. So now let's see a quick preview of our data frame. So right now we have these many number of rows, which is 1, 0, 8, 8, 4 and 11 columns. Now we can see the preview of this our first 5 rows. Now what I want to do is to find out or to filter out only those observations where count values are less than or equal to 200. So the way we can do is, what I'm doing, let's break down again. So what I'm doing here is that I'm telling Python, hey, can you list down all the observations where df count is less than equal to 200? So what it will do, it will find out in its memory that, hey, these are the, let's say 20 observations where df count is less than equal to 200. Now in order to display those 20 observations or 30 observation, we put this expression inside this bigger df. So bigger df has all the, let's say this many number of observations, and this particular inside one has only 20 observations. So what we are saying that, hey, can you subset only those 20 observations and or display only those 20 observations, and then store the output of those 20 observations or let's say 30 observations in a new variable called df1. So let's see how many observations are there which has count less than or equal to 200. So we can see that there are 6600 observations which has count less than or equal to 200, or we can see quick preview of what are those observations look where count is less than or equal to 200. So we can see that these are the certain observations where count is less than or equal to 200. Now a condition where multiple conditions are required. For example, let's say this one. It's saying that, hey, pick out those observations where humidity is less than equal to 80 and the count is greater than 15. So this particular symbol is an AND operator. So in the Pandas, whenever we use this one in the conditional, is called AND. And you know that when it's an AND, then both the condition has to be true or both the condition has to be satisfied, else it will become false. So what I'm saying is that, hey, identify those observations. First, identify those observations where humidity is less than equal to 80 and count is greater than 15. And whatever observations you have identified, now display those observations, store that output in new variable called df2. So we can see that this particular condition is satisfied by 7575 observations. So close to 7500 observations. Similarly, we can do OR condition as well. Instead of going with the AND condition, we can go with some OR conditions. So for the OR condition, this would be the operator, which is a pipe operator. And here we are saying the same thing. Less than equal to 80, humidity, and count to be greater than 15. So any of the condition gets satisfied or gets true, pick that observation. So in those two columns, any of the condition gets true, pick that observation, and then stored in df3 variable. So in our example, we have close to 10,000 observations, or more than 10,000 operations, or 10,000 observations with 11 columns. So this is how we can use like a filter conditions inside the data frame. So the next part comes up, how to convert Pandas data type from one form to another. It's very straightforward. It's very simple. Let's do a quick preview. So we see that the list of our data types along with their the list of columns along with their data types. So let's say, in holiday, it's giving float 64 data type, and we have seen that in our holiday, it's more like a 0 and 1. So instead of storing this column as float, let's convert it into a float. So what we are doing, we are picking that column df holiday and using the function called s-type dot s-type, and then inside that s-type, I'm telling what would be the new data type. So here I'm passing as int, so it means float to int, because originally holiday is a float data type, so I'm converting into an int now. It's done. So when we check the data type, now holiday has converted into int 32, so integer now. So the next part will come up the reset index. So let me run it. So we know that in our Pandas data frame or Pandas data series, we also get the index numbers as well, or the index labels, or the index name, or row number, or a row name, 0, 1, 2, 3. Now let's use a drop function to drop the index number 2. So what I am doing is passing the index number 2 and in place equal to true. What it will does, it has removed the row number 2, but 0, 1, 3, 4, 5. So if you try to search for a 2, you will not find it out. But let's say you want to reset the index. You want to reset the index so that the order should be in the continuity, like 0, 1, 2, 3, 4. Reset. Provide me the new index. Don't skip the 2. Replace 3 with 2, 4 with 3, 5 with 4. Now when we use this command df.reset_index, what we are showing, now it's showing me two indexes. The index which is the older index 0, 1, 3, 4, 5. The another column it's showing the new index or the reset index with 0, 1, 2, 3, 4. But we just want to keep the new one. So we need to delete this older index. We don't want to keep it because that's the purpose of resetting the index, because we don't want to store the index numbers, the older index numbers. So the way we can do is using the command, instead of using only df.reset_index, we will pass some parameters inside this circular function. So df.reset_index, so that will become drop is equal to true, means drop the older index, and in place is equal to true is yes, updated and stored inside this df variable. And when we see the df.head, we can see that the indexes all have been reset. Group by functions or the aggregation functions, same like the way we do the aggregations in the SQL through group by functions or pivot functions in the Excel spreadsheet. So in Pandas data frame, we have the options or the flexibility to do different type of aggregation using a group by functions. So let's do a quick preview of our data set. So we can see that we have this many columns, and let's define the problem, what we need to do in the group by. So the problem statement is that I want to see for every season how much is the summation of mean weather. So for every season, I want to see the total sum of mean weather column. So this is the mean weather column. I want to see the total sum of the mean weather across every season. So let's say if we have a 6 seasons in our data set, 6 unique seasons in our data set, then the output what I'm expecting is to get 6 observations, season 1, 2, 3, 4, 5, 6, or maybe 10. And then I want to see the what is the total sum of mean weather. So the way we can do in Pandas data frame is df is our data frame where we have stored our data. Dot group by is the function which we can use to do the summation, and then the next we will provide the dimensionality. So across which dimension we need to do aggregations or the summations or whatever. So in this example, we are using season. So across season we need to do the aggregation. So I'm putting the season column here. And then the next is a numerical column, which is that column where we need to do the aggregation, and that is mean weather. So so we want to know the summation of mean weather, and then dot agg, which is stand for I think aggregation, and I'm telling to Pandas that do the aggregation by doing summation. So find the sum of mean weather across every season. So when I run it, I will able to see the 5 season 1, 2, 3, 4, 10, and these are the total sum of mean weather. For season 1 is around 37,000, season 2 67,000 plus, and so on. So this is how we can use the group by function. But let's assume the next scenario or the next problem. We want to do the group by across 2 dimensions, not 1 but 2 dimensional, that is season and holiday. So the way we can do is just to add the next dimension or the next column. So since we already have season, so you will put comma and then the next column, which is holiday. So now I want to do the aggregation of mean weather across 2 dimensions, which is season and holiday. So across season and holiday, we can see that when season is 1 and holiday is 0, this is the total sum of mean weather, which is 36,000 something. And then when the season is 1 and holiday is 1, the sum is 674, and then so on. Similarly, we can do multiple column aggregation as well, multiple column aggregation. So what I mean is that, let's say you want to know the season, across season, what is my total sum of mean weather and count. So count, as you know, that one of the column in our data frame, which is you can say the total number of sales happened on that particular day or particular hour. So what we can do then in the numerical with square bracket, you can add as many numerical columns you want. So in our case, we have added mean weather and count, and then dot agg, which is aggregate, and we are telling to Pandas that do the aggregation by doing the summation. Through summation, do all the aggregation. So when we run it, we can get across season 1, this is our total sum of mean weather, and this is the total sum of count 3, 1, 2, 6, 3, 6, and so on. And similarly, if I want to do more aggregation, so for example, not only through summation, but I want to know for every season what is its mean value, max value, or a mean value, what we can do in .agg function, we can provide all those functions. So first, it will do the sum. It will find for every season what is the total sum for count. Then what is its maximum value, what is its minimum value, and what its average or a mean value. So when I run it, and we can find it. So for every season, it will tell me what is the total sum of count, which is this one for this column. What is its maximum value, which is coming to be 801. Its mean value is coming to be 1, and the average or a mean value is 116.69, and same for other seasons as well. So the next one, what we can do is to sort the values. Now the results what we have got is not sorted. So we can do the sorted as well. So let's say we want to do the sort by sum. So this is a sum what we have done. So let's say I want to arrange this season based on the values of sum in a descending order. So I want to see the output at a descending order. So the way we can do is in the Pandas, we have a function called sort underscore values, and the season underscore group by, we have already calculated all the group by output. It's stored in this data frame, and then I am inside the circular brackets. I'm telling that by equal to sum. So this is the sum column. So do the sorting based on this column, and then I'm telling ascending is equal to false, which basically means I want to sort it in a descending order. So when I run this command, now we can see that the output have been sorted based on the descending order of this sum column. So now the season 3 has the highest sum, which is around 640,000, and then season 2, 4, 1 and 10 based on this sum. So this is how we can do the sort values. The next function is a very interesting function, which is a pivot functions. So the pivot function is quite similar to the way we did or we used in Excel spreadsheet. It's the same thing what we did in the group by. It's quite similar to that, but it's just the syntax is little bit different. So in the pandas pd, which is alias name of the package what we have given, so pd dot pivot underscore table, then inside the circular brackets we are passing the data frame, which is our original data frame df, then index equal to season. So index is a keyword which you have to put it, and season in this square brackets you will put the name of all the columns where you want to do the all kind of aggregation. So you can say the dimension on the column. So in this example we are adding the season, then values equal to count, which is the numerical column which column you want to do all the aggregations, and then add func. So this is a function where I'm telling do two aggregations, one at the summation level and then another is the max. So you can see this function looks quite similar to our group by function. If I shrink it a little bit, so we can see that this particular function look quite similar to this one. Here season is a dimension. Here we are passing inside the index. Here the numerical column is count. Here values equal to count. In the values we are putting the count, and similarly here we use a double g, and here we are using a g func x func. So if you can see, it looks quite same. So when I run it, we will typically get the same kind of output. Now the next function what we are going to learn is a transpose data frame. So sometimes there could be scenarios when you have to do a transpose of a data frame to better understand the data, or maybe you want to use that transformation or a transpose data frame into some another data frame. So the way we can do is using the two ways. We can use this .t. So let's say I want to transpose this df dot transpose. So let's say df dot hat, this is a data frame, and I want to transform this. So when I do df dot t, we will see the transpose. So all those columns here now becomes this kind of like a rows, and all the rows have become the columns now. Now let's do df.describe. So as you know that df.describe will tell you all the statistical analysis of all the numerical columns. Now if I want to do a transpose of this, so the way we will do is that df.describe.t, and we can see we got the transpose of this data frame. So now we can see for season column, this is the count, this is the min, standard deviation, 25 percentile, max, and so on. So this is how we can use a transpose function. The next is apply function. Now apply function is a very handy function which we can use to do a lot of different quick functionality. So the way we can use is, let's say we want to add a new column. We want to add a new column in this data frame. So what I want to do is to add a square root. Let's say let me give you a snapshot. So let's say I want to do a square root of this count and store that output in a new column. So for example, if I do the square root of 16, it will 4, and I want the output this 4 in a new column. So the way we can do is we will give the name of a new column, which is count hyphen square root, and then I'm telling that df count apply this numpy function, which is square root, np.square root. So the moment when I run it and do a snapshot of our data, we can see that new column have been added, count square root, and we see the square root of 16 as 4, 40 as 6.32, and so on. So it's a very handy function .apply, which can be used for a lot of different smaller tasks where you don't want to run like a for loop and then do if and else. And so apply function will give you a lot of functionality to do a quick smaller tasks very fast, very easy, and easy to understand as well. Now apply and lambda function. So as we learned during the function module that lambda is another anonymous function where we can be used for do smaller tasks, and then with pandas we can use the apply and lambda functions together to do multiple different stuff. So let's say I want to create a new column which is called season status, and the way I want to do is to check each value of a season and see if the value of x equal to 1, then make it pleasant, and if value is greater than 0 or less than 2, make it sunny, else hot. So some kind of a if and else statement. So if you do in a very normal scenario, if you don't use apply or a lambda function, probably you will do that, okay, I will run the for loop, check each observation through if and else. If x equal to 1, then replace with pleasant, else do some other if and else. So we can see that it looks a very lengthy function, lengthy code, where first you're running the for loop, then checking the if and do all those assignment values. But with the help of apply and the lambda function, what we are doing here is from the season column df season, we are using the dot apply, and then dot apply we are writing this if and else. So lambda x, first it will check whether if x equal to 1 or not. If x equal to 1, it's true, then it will assign this pleasant value in the season status for that observation. Then it will check the next row and see if x equal to 1 or not. If x is not equal to 1, then it will go into the else block. In the else block, it again checking if and else. So if x is greater than 0 and x less than equal to 2, if x greater than 0 and x less than equal to 2, then assign sunny, else assign hot. So you can see that if I want to do as I said, if I want to do a for loop and if and else, then there are a lot of steps are involved, a lot of code is involved. But this one line of code is doing the functionality of for loop as well as if and else, and as well as assigning the values of pleasant or sunny or hot to this new column. So let me recap how it's happening again. Let me recap again. So what would happen that first it will pick the first row of season, which let's say season is 10. Then it's sent to x, so x become 10 now here, and then it will check the if and else. So here if x equal to 1, it fails because x is 10 right now. It goes into this else block. It will fail here because x is greater than 0 and x less than equal to 2, but our value is 10, so it will go into else hot. So this hot will assign to season status. Now let's say it picked the row number 4, which has season 1. So now this season 1 goes to x, and then it will check all those conditions, and based on the condition it will assign the output to season status. So another way what we can do from this apply lambda, we can call a function as well. So here we are doing the same thing, season status, I'm creating a new column, season status and apply. It's doing the exact same thing what we did above, but in a different way. So what we are doing, we are passing each observation of df season column. Then dot apply is the function, and it's saying that apply this particular stuff, lambda x season status x. So season status, we have created a new function, season status x, and we are passing all those if and else condition here. So if x equal to 2, status equal to present, elif, and so on. So the way it's happening is that, let's say first it will check the first observation of season, which is 10. So this 10 will go to the lambda x. So the value of x will become 10. Then it will call the season status function and pass the value of x10 in this function. Then in this it will check the if and else. Basically all the above two if and else will fail. It will goes to status equal to 10, and it's saying return the status. So return the status means return that value 10, and it will assign to season status underscore apply. Let's say now we are checking the season column value 1. So what would happen that it will go into this x, the value of x will become 1. It will call the season status function, pass the value of x equal to 1 in this block, and then this condition will get true or satisfy, x equal to 1, status equal to present, then it's done, and then it returns the status value and it will get assigned to season status apply. So let me run it, and we can see that new status have been or a new column have been created, season status underscore apply, and we can see all those values here. Although I didn't run this particular command, so let me run it and let me see the output again. So we can see that season status apply and season status what we have created above all have same output, because we are basically doing the same thing but in a different way. So if you feel it's little confusing here, you know how this if and else is working here, it is quite confusing. Maybe you can break down the code in this way. At least in this case, you have saved yourself of using for loop, because if you use the for loop, then it will run from 1 till the end, till the exit condition meet, and then it will check one by one. It takes some time, especially when you have a huge data set. But with this, it's quite fast and easy to understand as well. And similarly, we can also use apply function to check whether a value is meeting certain criteria or not. And then, so let's assume that we are checking whether the value of count is greater than 100 or not. So if it's greater than 100, then put some value. If not, then obviously assign some different value. So let me run it and show you the output. Now for the count and status, it's checking the value of count. Here it's checking whether x is greater than 100. If x is greater than 100, this command will basically put boolean values, either true or false. So since so whenever value of x is greater than 100, the count status have a value true. If it's less than 100, because the condition has failed, so the value would be assigned as false. So we can see that for this count, since the value is greater than 100, which is 191, so count status column, the new column what we have created, will get the value as true. Whereas here the count is less than 100, which is 13, so the value will be assigned false here. So this apply lambda combination automatically will assign some boolean value true and false. So that is also very handy, because again we use some different method, which is for loop or if else. We have to assign true or false, but here it's doing us automatically. So it saved some time, saved code, and it's much faster. Now the next one is a Crosstab function. So Crosstab function will tell you across different dimension how many observations are present. So for example, let me give you an example. Let's say we want to do across season and holiday. So in the Pandas, we have a function called Crosstab, and we are passing two columns, season column and the holiday column. If I run it, it's basically telling me when season is 1, when the value of season is 1 and holiday equal to 0, how many total number of rows or observations are present in our data set. So we can see that when season equal to 1 and holiday equal to 0, so total number of observations are 2608. Similarly, when holiday is 1 and season is 1, we have total number of observations are 71. And similarly, if you see for season 4 and holiday 0, we have 2638 number of total observations in our data frame. So this Crosstab will basically tell you the total number of observations or the frequency of observations. So we can see that when whenever the holiday equal to 0, we have more number of observation as compared to the holiday one. So in this way, we can use a Crosstab function to find the total number of observations or frequency across different dimensions. Now let's learn about the next concept, which is datetime function, which is very important because in our data set in a real time, we will going to have a columns where we have a datetime columns or some kind of a seasonality column or some kind of a transactional column where it's telling me that on that day we have this particular transaction. So let me run and see the data type. We see that we have a column date, but its data type is given object, which is like a string. So in order to use some of the functions of datetime, first we need to convert this date object into datetime. Then only those Pandas datetime functions will work. So the way we can use the package which is datetime. So there is a package available, import datetime, and we are giving an alias as dt. So now what we are doing in order to convert this date from object to date time is using this function. So in the pandas we have function called to underscore date time and then passing the name of that column and then assigning the output back into here. So now we can see that the data type of date has been changed to date time 64. Now whatever date time functions are there, we can use it now, because now the date column is in the absolutely right format. Now let's say let me run it. So let's see the preview of our data set. So now we can see that in the date column we have a year, month, year and time. Let's say I want to create a new column which is storing the month of each observation or date and the year. So or extracting the year from the date column or extracting the month or extracting a day. So the way we can do, let's say I'm creating a new column df month and then from df date dot dt. So dt, if you remember, we just loaded this package date time and giving the alias as dt, so that whenever we use this package we use its short name as dt. So dot dt and dot month. Similarly we are doing to extract the year from the date column and extract the day from the date column, and this is done. So if I run it, we can see that at the end of this data frame we got a new column. Yeah, so we got 3 new columns, which is month, year and day, and it extracted the month, year and day from that date column. So another way what we can do is sometimes there could be a scenario where we want to convert the format of a date in some different way. For example, I want, instead of having hyphens, I want to convert in this format, like first I want a month, then like a slash, then I want a day, and then I want a year. So we can do using this from the dt package or datetime package. There is this function called strf time. So when I run it, we can see that now the date format has changed in this way. So first it's showing the month, then day and then year, which is separated by a slash. So, and similarly we can also convert this particular thing, or if I want this date column in some other different format. For example, I want first month, then D and then year, but they have to be separated by a hyphen. So the way we can do is, so we can see that the moment we have converted this into in this format, it has converted into an object. Again, it has converted from date time to a string. So that is very confusing, because the reason it has converted into an object because of those forward slash or a backward slash. I really get confused whether it's a forward or a backward. So let's say because of the slash thing, Pandas has converted this date column back into the object. So same thing, first we have to convert into a date format, and we can see that, you know, the date has again back to date, and we can see now now I want month, day and year, because in our older example we have year first and then day and then month. In this format I'm saying that make month first, then day and then year. So when I run it, I get an output 0 1 0 1 1. So year is your 11 is your year, and this first 0 1 is your month, and the next 0 1 is your day, because this is the format what we have given here. Now let's learn how can we combine multiple data frames into one. So right now in our example what we are doing is using only one data frame, but in real world we can have multiple data frames, and we want to join those multiple data frames into one. So the way is the way we do the SQL. So if we have a multiple tables in our SQL, we typically use joins, left join, right join, to make a one single unified table. Similarly, we can do same thing in Pandas packages as well. If we have a multiple data sets or a multiple data frames, we can use joins and concatenation to make a unified single table. So let's say df1 is the first data frame or the first data set, and we can see that this is the preview of our data set, which has around 12 or 13 columns in it. And then I am loading the second column or a second data frame and storing the output in df2. So this is the df2. So df2 is more like a reference data frame. So for example, in our df1 data frame, we have a store number, but we don't have a store name in this data frame df1. But df2 has a store number and this store city. So this store number belongs to which city? Store number or store city. So df2 is basically a reference data set where it's storing the cities of each store number, and our objective is to combine these two data frames into one. And we can quickly see the shape. So we have for df1 we have around 438,000 observations and 13 columns. For df2 we have 70 observations on 2 columns. So, or I can say in df2 we have 70 stores, 70 unique stores, and we have the name of all those stores in it. So let's say if I want to join these two tables based on the left join, and the way we can do is use the pandas package pd. So alias name of pandas we have given as pd, the short name. So we are using the short name pd. Dot merge is one of the function which is available in pandas. So df1 is the left table. This would be our master table or the left table. df2 would be our right table, and then on is equal to store number. So basically we want to join based on the key or the column called store number. And the way we want to join it, how? So it's asking how you want to join it. So we are telling join it based on the left condition. So what it will do, wherever, so as you know that in the left join, we will get as an output table, which would be df3 as an output, we will get all the observations which is present in df1. So the output we are expecting to have this many number of observations. In wherever the store number will get matched with the df2, it will add the store city as Arizona, and wherever the store number will not get matched or it's not present, it will put store city as null in the df3. So let me run it and showcase it. So that's what I said, that in the left join, so whatever total observation present in the left table, which is in our case is df1, we get the same number of observation in our output data frame, which is df3, and 14. So it means new column has been added, that could be store city, and we can see that now for every store number AZ2, we got the store city as well. And as I said that for this particular store number, which is AZ23, this particular store number is not present in our right table, which is df2. So since it's not present in our df2, we got the blank values. So this is how our left join will work. Now instead of doing the left join, let's say I want to do an inner join, because I want to make sure that in our output data frame we have only those observations where store city is present. So the way we can do the same thing, df1, df2. So we are joining based on the store number, but this time we are telling we want to do an inner join. So wherever that store number value gets matched between both the tables, then only pick those observations. So we can see that we have this many 1, 3, 6. So it means that there are a lot of store numbers which are present in df1 but not present in df2. Since it's not present in df2, because of the inner join, it drops those store numbers which are not available. So it has picked only those store numbers which is present in both the files, and then filter out or delete the ones which are not present. And similarly we can say about the right join also. So if I want to do a right join, we can use the how equal to right and same thing, and we get the output. So this is how we can do a joins in pandas. using left join, right join, and the inner join. There is also outer join as well. The same thing you can do, instead of right or inner in the how, you can put it as outer. So you can try yourself and see what output you get. Hopefully this join concept is you are able to understand. It's a very straightforward in Pandas, and you can make it as complex as you want, but the idea of this session is to give you the overview, how can we use and provide the fundamentals of joins in Pandas. Let's say you want to join more than 2 tables. So right now we have only one table or 2 tables only, and we are joining those 2 tables. Let's say we have a scenario where you have 3 tables and you want to join those 3 tables based on certain condition. So the way we can do is we can use the same merge function, but this time the syntax is little bit different. So here I'm passing df1, which is my first table, dot merge. Then I'm joining or merging with a df2 and telling that it has to be done through inner and on this column, which is store number. Then dot merge. So the output of those 2 tables then merge with my third table, which is called df2. And I'm doing the similar condition inner and on those. And if you have the 4th table, you can do again dot merge and provide the condition. So this is how you can join more than 2 tables if you have in your data set. So if I run it, I will get this kind of an output, because we are doing the inner join in all the joins. So it picking only those rows where the particular store number are present in every way. The next way we can join it is through concatenation. So there is another way we can do the concatenation. Instead of joining the 2 tables based on certain condition like inner join or through some column key, we can do some concatenation as well. Concatenation means we can append the second table to the right or to the below of it. So let's say I'm creating 2 series data frame, L1 and L2. And what I'm doing is that I'm concatenating L1 and L2 and storing this concatenation or single output into L3. So we can use the Pandas functions PD dot concat, PD dot concat, and then inside the circular brackets, I'm passing this L1 and L2 inside the square brackets, and x is equal to 1. So far we have learned when we say x is equal to 1, it means we are saying do something towards the column side. So when we put x is equal to 1, so what it will do, it will append new column. So it will append the second one to the right of the first one. So it basically add new columns in it. Or we can see that this concatenation will head sideways next to each other. So when I run it, we can see that these have joined across columns. So the first column is name is 0, second column is 1. So because of the x is equal to 1. So whenever you want to do a concatenation next to each other or sideways or add a new columns, then go with this x is equal to 1. Now let's say I want to, instead of doing sideways, I want to do one below the other. So in that case, we will put x is equal to 0, because we are not adding a new column, but we are adding a new number of observations. So in this way, we will put x is equal to 0, and we can see that now the concatenation one below the other. Instead, but in the previous case, it is happening across columns next to each other, but here it's appending one below the other. And the last part of this exercise is how to read and write CSV and Excel files. So the way we write any output, so let's say we have already created this output L3, which has 2 columns 0 and 1. Let's say we want to store in some CSV file. So the way we can do is to use to_cv function. So L3, which is the name of that variable which we want to store, L3 dot to_cv. This is one of the function. Then inside the round or circular brackets, I'm passing, yes, we want to store the CSV file, but in which location and what would be the name of that CSV file. So I'm not passing the location because I'm storing in my local folder from where this notebook is running, but I'm giving the name as demo_csv file.csv. and comma index equal to false. I don't want some row number or index number. I just one column, which is L3. And similarly, we can write down into Excel file as well. So L3 dot to underscore Excel, and the rest would be absolutely same. So when I run it, done. So CSV or Excel, I'm pretty sure would have been created there in my local folder. Now, in order to read those CSV and the Excel file, the way we can use is use the Pandas package pd dot read underscore CSV. So read underscore CSV means read the CSV file, and then you will provide the location where you have stored the CSV file and the name of that CSV file. So as you know that we have created demo underscore CSV file dot CSV. This is what we are doing here. We are reading this file now and storing that output of that CSV what we are reading into CSV data. And same we are doing with the Excel file pd.read underscore Excel. This is a function to read any Excel file. So let me run it. And now it's reading the CSV and Excel file and then stored in CSV data and Excel data. So when I run it CSV data.head, we can see that we were successfully able to write and read because this data exactly matches with this one. And similarly, when I do Excel data, because in the both CSV and Excel we are storing L3, so that's why both the output looks same. So in this way we can read, write into CSV and Excel file.